I can combine these two sums into one sum because both of them are finite. They're both finite sums. And so you can factor out a delta x from each term, right? And then I can combine the f of x's into one argument. Okay, so this line is essentially a bunch of factoring. And so now if I use this summation, I basically expand it out. So when I is equal to 1, I plug in 1 there. I get f of x sub 0 plus f of x1 plus, if I plug in 2 in for I have f of x1 plus f of x2. If I plug in 3 in for I have f of x2 plus f of x3, and so forth and so on, until I get to essentially the last one when I plug in for I. Does that make sense, where this comes from? So it's just expanding that out. Okay? And then the last line, what you notice is what happens here. Well, all the terms on the inside repeats itself, right? It doubles. So you have f of x1 plus f of x1, you get 2 f of x1s. And then the next term here, you're going to have an f of x2 and another f of x2 here. And how many of those do you have? 2 f of x2s. And so forth and so on. So everything in between, you're going to have 2 of them, except for the one at the beginning and the one at the end. Does that make sense? Okay? So T sub n, that's the formula. It's going to be delta x over 2. It's going to be times f of x sub 0 plus 2f of x1 plus 2f of x2 plus 2f of x sub n minus 1 plus f of xn. This delta x is just like before. Delta x is b minus a over n. So just like before. Now, why is this called the trapezoidal rule? Well, that's because if you look at this picture, what do you see? You see a bunch of trapezoids, right? Okay. So essentially, a trapezoidal rule is you're adding up a bunch of areas of trapezoids. Okay. So to kind of see why this is why you get a trapezoid or a bunch of trapezoids, what's the area of a trapezoid? Do you guys remember? Half base. How many bases are there in a trapezoid? Okay, so what's the area of a trapezoid? that's how we get there. That's true. So let's see if you could help me out here.
Isn't it 1/2 base 1 plus base 2 times the height?
That's what I want to say. That's why I'm not 100% sure. It's been a while. So. If it's not right, then we'll tweak it.
Wouldn't it be base 1 minus base 2 to give you the...
I feel like there's something wrong with the formula. I remember there being a plus.
Yeah,
all right, all of you have smart.
It's area equals a plus b over 2 times height.
A
Which is
plus
what we have.
B, that's what we have. So A, okay, that's fine. Okay, good. Okay, so if I look at my picture here, look at your first trapezoid, right? So what's the area of that trapezoid? So this is going to be right here. That's going to be f of x sub 0. And that's going to be f of x sub 1. So the area of that is going to be that one particular trapezoid, okay? It's going to be 1/2. What's the base? What's one of the bases? Tell me where the base is. One of the bases. I'm not talking about baseball here. Close. It's going to be the height, right? Or this length right here, right? Isn't that one of the bases? The other base is that one. So what dictates the length of that base? Is it going to be x sub 0 or is it going to be f of x sub 0? Huh? F of x sub 0, right? So f of x sub 0 is going to be the first base. First base. Okay. Plus, okay, we're heading to second now. Add up the height, or the base number 2, so it's going to be f of x sub 1, right? Times, what's the height?
Delta x.
That's going to be the height, so the height is delta x. Okay, so look at this right here. Isn't that what we have here? Yeah. So this right here gives you the area of the first trapezoid. The second trapezoid is given by that, because you need the delta x over 2 to carry through. That's why it's on the outside, it distributes through. So each of these terms, these groupings, give you another trapezoid. So that's where the trapezoid is. Does that make sense? Any questions on that? Okay. So in terms of, again, you can derive this formula if you want, but what's the pattern here for this formula? So you have your delta x over 2. So instead of delta x, you have delta x over 2 for your trapezoidal rule. Okay. Why? Because the area of a trapezoid, it's 1/2 times something. Okay. And then if you simplify the inside, what do you get? Well, the pattern is the first and the last endpoints, they're by itself. Everything in between are multiplied by a factor of 2. Does that make sense? So you have 1s at the ends, and then everything in between, they're all going to have 2s. So, let's do the same thing. So same function. And let's see if we can use the trapezoidal rule to get an idea of how well that estimates our area. Okay. So let's find t sub 4. Okay. So t sub 4 is going to be delta x over 2 times f of, let's go back to here.
F of 0, right?
Well, let me redraw it. So I'm just going to draw the interval. So it's going to go from 0 to 2. My delta x is b minus a over n, so it's going to be 1/2 again. So the ones at the end are 0 and 2, right? So it's going to be f of 0 plus the ones in the middle are going to be multiplied by 2. So it's going to be 2f of 1/2 plus 2f of 1 plus 2f of 3/2 plus, and now the last one is also going to be just 1. So it's going to be plus f of 2. And so delta x over 2 is 1/2 divided by 2, which is 1/4. F of 0 is going to be e to the 0 plus 2 e to the 1/2 plus 2 e to the 1 plus 2e to the 3/2 plus e to the 2nd. So I'm using f of x f of x equal to e to the x again. So we're approximating this again. Okay, so just like from before. So I'm applying the trapezoidal rule to the midpoint example from before. Okay, same function. Is that okay? So for me, the hard part is actually typing this into the calculator correctly. Okay, so assuming that you can do that, I got 6.52. I don't know if someone can confirm that. So the midpoint rule, we got 6.32. The trapezoidal rule, we got 6.52. What's the error? So the error, which is bigger? Which has a bigger error? Midpoint or the trapezoidal?
Trapezoidal.
Trapezoidal, right, had a bigger error because this is 6.52, 6.32. 6.32 is closer to 6.38, which is what we want, right? We want to be as close to this as possible. So it looks like the trapezoidal has a bigger error. Is that a coincidence? Is that always going to be the case? What do you think?
How is it that the trapezoidal rule gives you too much area? Because all of the parts that you're missing are inside.
Well, our function might not look like that.
Okay.
Yeah, yeah, e to the x I don't think looks like that. So for a function that is kind of
Okay, I guess so.
concave down like that, right? So e to the x doesn't look like that.
Right.
Yes.
On the midpoint,
Yeah.
where did the x, I don't know where, I'm not sure where x squared went, because we just plugged in the,
What do you mean by x squared? I'm not using this. I'm not approximating this.
Oh, okay.
I'm approximating this.
oh, okay.
The reason why I'm not approximating this is because I want to actually show or try to figure out what my actual error is. If I use this, there's no way for me to know what my error is unless I use a calculator, which to me is like, cheating is such a bad word, right? But if you use a calculator to find this, then the calculator's approximating anyway. So yeah, the x, I'm not approximating e to the x squared, I'm approximating e to the x. You get that, Elizabeth? We're approximating e to the x, okay? So it's the first time I talked to you today. Has she started watching the videos yet?
I don't know yet.
Oh.
She hasn't responded about that. She said she was going to look at them last night.
She probably has better things to do, right? So make sure you approximate the correct function. Make sure you guys approximate the correct function.
She'll be back tomorrow. She's got a flight at like 5 a.m.
That's cool. Eastern time?
Yes.
Oh. Hope you had a safe flight. Okay. Any questions on that? Make sense? Okay. So tomorrow we have one more technique. The Homer J. Simpson rule. Okay. Simpson's rule. Homer J. makes it sound more fun. Okay. So out of all the different rules, Simpson's rule will be the most accurate because midpoint, right endpoint, left endpoint, they all use rectangles. Trapezoidal rules use trapezoids. Simpson's rule actually uses parabolas. Okay. So we'll talk about